All right, episode whatever we're on, LT7. Um, this is all about applying quadratics into some kind of examples that either are problem-solving examples or later we'll see one with like projectiles that is kind of more like a real-world thing. So the actual solving I'm going to go through pretty quickly because we've spent so much time on solving. I'm going to try to focus a little bit more on the setup in getting an equation set up, and then I'll kind of skip through the solving fairly quickly. So two examples here. The first one's pretty simple. It says the product of two positive consecutive integers is 156. So first of all, product, that means multiply. So I'm multiplying two positive consecutive integers to get 156. If they're positive and consecutive, I'm going to say that the first integer is x, and the second integer, since they're consecutive, is x plus 1. So here's the setup. X times x plus 1 equals 156. Before I can solve this, I can't use zero product property first. This is what some people were making a mistake on the checkup. I can't. It looks factored and it looks ready to go, but I can't solve this yet because this isn't 0. So first I have to expand this, and I get x squared plus x equals 156. Then I subtract 156 from both sides. So I'm really just going to make this minus 156 equals 0. Then I have a few options as to how to solve this. This looks like something that might be easy to factor. So let's start looking for factors of 156. And I'm skipping a little bit of this just because we don't need work on factoring, but that factors into a 12 and a 13, and to make this equal to x, I want this 13 to be positive and I want the 12 to be negative, so this is going to be an x minus 12, x plus 13. Now, if I finish solving this, I get my answers as x equals 12, x equals negative 13. But it says two positive consecutive integers. So let's get rid of the negative answer. The two integers are 12 and the other one, the next consecutive one, 13. So the answer is 12 and 13. All right. In the second one here, again, I'm focusing on the setup. So we've got a rectangular pool measuring 10 meters, its length measuring 10 meters more than its width. So a little picture is drawn here to help you out. Here's the length, or excuse me, here's the width, and here's the length. It says the length is 10 meters more than the width, so that's why we have a width of x and a length of x plus 10. Now it says the area is 875. To get area, I multiply the length times the width, so I have x times x plus 10 equals 875. And just like I did before, I'm going to expand this and then subtract 875 from both sides so that it equals 0. That factors into x plus 35, x minus 25. And if we think about our two answers here, we are again going to rule out the negative because we can't have a negative length. So the length of this pool is 25 and the width is 35. Okay, and so those are the dimensions of the pool. In this next one, this is a projectile example. Um, the graph here shows the flight of the stone. In this equation, h equals negative 4.9 t squared plus 17t plus 2.2 shows the height of the stone over time, where t is in seconds, h is in meters. So as time goes on, this is what the stone does. It goes up into the air, maybe reaches a peak of about 17 meters in the air, and then falls back to the ground. So first, just some estimating. When was it 10 feet tall? Right about there and right about there. We're just kind of looking at the graph and estimating maybe a little less than 1 second and a little more than 3 seconds. What was the height of the stone when it was thrown? So somebody probably threw it, or some catapult or launcher or gun or something. And it looks like it was maybe a little more than 2 meters off the ground when it was thrown at time 0, t equals 0. But now we are going to use the equation to get more exact answers to these questions. And I want to focus on this question: when is it 10 feet tall? So we're going to use the equation here. And I want to know when it's 10 feet tall. So in other words, I want to know when h equals 10. So I'm going to plug in 10 for h. 10 equals negative 4.9. Before we can choose any sort of method to solve this, we need to get this 10 off of here, and we need to make this 0. So I'm going to subtract 10 from both sides. This is going to be negative 4.9 t squared plus 17t minus 7.8 equals 0. Now it's ready to solve. You can tell probably by looking at this for like half a second that you're not going to be able to factor it. Because of this t term here, this is not going to be able to be solved by square rooting. So this is going to have to do quadratic formula. I know a lot of you need some more practice with quadratic formula, so I would say pause the video right now. When you unpause it, I will have the steps there for how to actually solve it, and then you can check over it. So try out quadratic formula with these crazy decimals, and unpause when you're ready to see the answer. Alright, so after some weird decimals and some number crunching, this is not exactly the easiest thing to solve, but after doing all of that, you can follow through with my steps there, or pause if you want to see it. We get t, or time, at about 0.54 seconds or 2.93 seconds. And if we look at the graph, it looks like that would be about right. Here's about half a second. If we just kind of estimate and look down, this looks like it's, not quite 1 second. I wouldn't have maybe estimated 0.54, but that's what it comes out to be. And then here, if we kind of follow it down and estimate, it looks like it's right about at 3 seconds, and that's very close to 3 seconds. So what we just found was that at time 0.54 seconds and 2.93 seconds, the height of this stone is 10 meters. Okay. I want to remind you one more time, don't get all caught up in the solving of it. It's a tough thing to solve. It gets messy, but that's fine. The most important step to me is this interpretation right here, taking the h equals 10, plugging it in for h, solving for t. That process is the biggest thing that I want you to get out of this. And if you understand that, then you're good to go. For the before class, Susie wants to build a garden that has 3 separate rectangular sections. She wants to fence around the whole garden and between each section as shown. The plot is twice as long as it is wide, and the total area is 200 feet. This is the key right here. It gives you the total area is 200 feet. To find the area of a rectangle, you multiply the 2 dimensions, and it tells you that the area is 200 feet. So that's my hint to you as to how to set this up. That will help you set up an equation, then solve it for x, just like we did on this pool problem. And once you find x, then figure out how much fencing she will need. That's kind of the last step. Find out the fencing that she will need to fence in that garden, as shown.